Hello, class. This is problem number 11 from page 113 that I think some of us struggled with, so I'm going to do it again. So here's the bus stop. Elena is right here, and she's trying to figure out the fastest way for her to get over to the bus stop. And she wants to get there as quickly as possible. So the question is, does she go all the way down? Where does she cut across the park? Does she cut across the park here? Does she cut across the park over here? That's what we're trying to find out. Where does she cut across the park to get her to get her to the bus stop the fastest? Okay. So we're just going to pick just a random or arbitrary value. We're going to say we don't know what we want her to cut through the park somewhere. We don't know where that is. That's what we're trying to figure out. So we're just going to call this x, and we're going to call this 2000 minus x. And it doesn't have to be close. I have no idea, right? We're starting this problem. We don't know where she's cutting, so that's why we're just using x. And again, we want to optimize this, so we're going to try and figure out how we can relate this using some other mathematical formulas that we know. Find the derivative, because that will give us the critical value, and then it'll help us find out how she can optimize her trip. Now they give us speeds here, or rates, and we're going to use that. She has a different rate when she's walking this way, right, on the sidewalk here, versus when she is cutting through the grass. When she's cutting through the grass, she's walking slower. When she's cutting through the park, she's walking at a slower rate, so we have to keep that in mind too. So there's two parts to this. The part that she cuts through the park, and the park that she, walks on that sidewalk. Walks on. So we're going to calculate those lengths. We're adding those together because this plus this is her trip to the bus stop. And we're going to find the derivative of that since we have them in terms of x. And we'll figure out where she needs to cut through the park. Okay. I'm kind of limited for space, so I'll be kind of erasing stuff as we go along. Okay. So this part here for x, well, this is a right triangle. And this line here I have in green is the hypotenuse of that right triangle. So that's going to be just the square root of x squared plus 600. And that's the length that she'll be cutting through the park. And remember, when she cuts through the park, she's going at 4 feet per second, so we're going to divide by 4. Plus the rest of the way, and the rest of the way is just 2000 minus x, just a straight line. And remember, that's over 6 because she is, her speed is faster when she's not cutting through the park. All right, so we're going to find the derivative. And let's go ahead and do this. I'm going to actually move this to another page because we're running out of room. I don't think we need the diagram anymore. So let's see here. So we had the square root of x squared plus 600 over 4. And we had plus 2000 minus x over 6. Okay. And let's see. We can do the quotient rule for the first one. So, whoops. Let's move that over. So the numerator is x squared plus 600 to the 1/2 power, and the denominator is 4. And so the derivative of the numerator is the chain rule, right? 1/2 x squared plus 600 to the negative 1/2 power times 2x. And the derivative of 4 is just 0. And so the derivative of that first term is, let's see, 4 times, actually it's 4 times 1/2 times x squared plus 600 to the negative 1/2 times 2x, and it's minus 0, so I'm not going to bother putting the 0, over 4 squared, which is 16. All right, let's clean this up a little bit. So the numerator, 4 times, so we have here 4 times 1/2 times 2x. So 4 times 1/2, that's just 2, and 2 times 2x, that's just 4x. So I have here, whoops, 4x over, and since it's a, whoops, it's a negative negative exponent, so that's going to go on the bottom, x squared plus 600 times the 16 that's already in the denominator, and I can even reduce that. So now I'm left with x over x squared plus 600 to the 1/2 power times 4. And I can put the 4 in the front if I want, but there's the derivative of the first leg of her trip. And now let's go back and deal with this 200 minus x over 6. This derivative is going to be a lot easier because watch what I'm going to do. There's no square roots or anything. I can rewrite that fraction as 2,000 over 6 minus x over 6. And if I take the derivative, well, guess what? 2,000 over 6 is a constant, so that just becomes 0. And negative x over 6, that derivative is just negative 1/6. So if we put everything together, when will x over 4 times x squared plus 600 to the 1/2 power, whoops, minus 1/6 equals 0. And I'm going to add 1/6 to both sides. So we have everything. Just now we're back to algebra 1. X on one side, everything else on the other. So x over 4 times x squared plus 600 to the 1/2 power equals positive 1/6. I need to get rid of that square root, so I'm going to square both sides. So I end up with x squared over 16 times x squared plus 600, and that's going to equal 1 over 36. And let's see, I'm going to cross multiply here, 36x squared. So this is what I'm doing, guys. Look, this times this, and this times this. 36x squared equals everything in that denominator times 1. So, and I'm going to go ahead and distribute that. So equals 16x squared plus 16 times 600. That's just 9,600. Okay, let's get all this. Let's see. Let me move the 60 next to the other side. So 20x squared equals 9,600. Divide both sides by, well, let's move everything to one side, because if we factor, we don't want to miss any solutions. Let's see. 20 is going to be my greatest common factor, so 20 x squared minus 480 equals 0. So when will x squared minus 480 equal 0? When will x squared equal 480? Take the square root of both sides. Let's see here.